Can you all see my screen?
Yes, I can hear you. I can see your screen, so I think we're good to go. My watch also says we're ready, so take it from here.
Okay, thanks. Then, yeah, once again, thank you very, very much for the nice introduction. And today I'm going to present joint work with a former master's student of mine, Alessandra Corvonato, and with my PhD supervisor, Christian Heumann, also from LMU Munich. And we thought that it might be a nice little research question to reevaluate the GermEval task 2017 using yeah, all of the pre-trained language models which are nowadays available and suitable for the German language. Just to give you an overview on the basic problem setting, what is the GermEval task 2017 even about? The organizers of this shared task collected social media feedback on the German public railway company Deutsche Bahn, in short DB, and then manually annotated this corpus in order to be able to perform 4 different subtasks, all of them kind of related to aspect-based sentiment analysis. And they thought of this whole thing as a kind of pipeline, step by step, getting always closer to this, to real upside. The subtask A was a simple binary classification task they called relevance classification, where the task was just to identify whether a tweet or some feedback on social media was even about Deutsche Bahn. So just a binary classification task. The second one was a little bit more complicated. It was a document level sentiment classification task with 3 categories: positive, negative, or neutral. And then it gets even step by step more complicated. The next one can actually be already called aspect-based sentiment analysis. It was a multi-label task where the task was to detect whether the text contains a combination of these 3 sentiments mentioned above here with 20 different aspects, like, for example, the general atmosphere or the technical equipment or stuff like this. And they subdivided this task into 2 different subtasks, C1 and C2. C1 was about just detecting the aspects, so a multi-label task with 20 categories, and the second one, C2, was about basically detecting the combinations. So in total, 60 different categories. Subtask B was then about to detect the specific expression, which expresses the sentiment towards some of these aspects. And this was then a sequence labeling task where we have a label for each word in the sequence and have to determine whether it belongs to an aspect or not. They also collected 2 different test sets. One they called the synchronic test set, and the second one they called the diachronic one. The difference was the time period during which the data was collected, since the diachronic test set was collected half a year later in order to somehow to control for temporal robustness of the models. And what made this shared task from 4 years ago interesting for us was that back then mainly traditional classifiers were used, stuff like SVMs or LSTMs and so on. And since then, only some other researchers tried to tackle the problem using more advanced models. The second research goal we wanted to tackle is kind of to compare our findings to the results from the English language, because as most of us know, NLP nowadays is kind of English-centric, and we have a vast amount of benchmark data sets for the English language, like, for example, GLUE or SuperGLUE, or even this SEMeval task we're going to talk about later. And all these English benchmark data sets are used for developing and evaluating the state-of-the-art models. And conclusions, at least this is kind of my impression on this whole topic, are easily, are often just transferred to other languages. And people think what works good for the English language has to work good for other languages too. And the problem is basically that the amount of non-English pre-trained language model is always growing. But for other languages, kind of these standardized resources, like for example, glue or superglue, are kind of missing. So we do not have these standardized evaluations of different models for example, German. And this is another comparison we're going to draw in the end. So what we wanted to do was to evaluate currently available German pre-trained language models on these tasks, cased versus uncased models, German versus multilingual models, and also BERT versus distal BERT models. And then we kind of wanted to draw parallels from our observations to the development of the state-of-the-art performance for English, aspect-based sentiment analysis, as already mentioned at the example of this popular GermEval 2014 datasets. And also to compare the BERT-based approaches we're performing here to this pre-BERT approaches from 2017. Here's a quick overview on the 7 model variants we investigated. It includes, in total, 4 pure German models, 2 of them cased, 1 uncased, and also 1 cased distal BERT, 2 mBERT models, 1 cased and 1 uncased model, and the multilingual distal BERT cased model. The difference between these German models is basically who pre-trained them. One is by DBMDZ, and the other one was pre-trained by DeepSet.ai. And yeah, these were kind of the architectures that were available via Hugging Face at the end of 2020. Sorry. Here's an overview what happened on what happened before and also what we did. The models from 2017 behind this row. I mean, this subsumes all the models that were submitted or were found in these proceedings from Wojatzki and colleagues, basically 8 models. And this one was later on also submitted by the organizers. And this row basically does not mean that each of the participants from 2017 performed each of the tasks, but yeah, most of them performed Subtask B, Subtask C and D were tackled less often. We evaluated the models on all of the tasks. And here's what happened between 2017 and today. There were a couple of other researchers who tried to tackle the problem. Some of them also already using BERT-based approaches, but also many things using ELMo or fast text embeddings. And we're going to always include these in our comparisons when suitable. Yeah, Subtask A, remember this was the relevance classification task. The best model back then was an XGBoost model by Sayed and colleagues, and they achieved an F1 score of roughly 90%. And all of our BERT models were kind of better by a margin of 4 up to 5 percentage points. The best one, and this will also be a quick spoiler, this will also be the case for the rest of the task, is basically always this uncased BERT-based model. And yeah, we're going to quickly talk about this in the end, why this might be the case. We have some speculations, but yeah, basically no definitive answer why this is the case. So from this pretty easy task to the next slightly more complex task, the document level polarity classification. And here again, we have, I forgot to say this, we have 1 column for the synchronic test data set and 1 for the diachronic test data set. 2017, there was, again, this XGBoost model was performed best on the diachronic test data, while an SVM-based model by Ruppert and colleagues performed best on the synchronic test data set. Again, in this middle part of the table, you can see our 7 BERT-based models. Again, the strongest performance exhibited by the uncased BERT-based model by DBMDZ. And the worst model performance, and this was, I think, already the case already also here, is exhibited by the multilingual BERT-based model. In between, there were many researchers also interested in this task. And as you can see here, already Biesialska and colleagues in 2020 and also Guhr and colleagues in 2020 were pretty close to the performance of our BERT models, since they here used ELMo embeddings with some attention module on top, and here also the BERT-based German cased model from huggingface. Maybe the performance difference here can be explained by the different data splits. Guhr and colleagues used some custom data split and did not rely on the official data split from 2017, which kind of limits the comparability to our results. But the numbers we report here are the numbers from the unbalanced data split, since the original data splits were also pretty unbalanced with respect to the sentiment. So yeah, not perfectly comparable, but maybe somewhat. For Subtask C, we had this separation to aspect only and aspect plus sentiment, 20 classes here, 60 classes here. And here we were also able to significantly increase performance over the performance back then by around somewhat over 20 percentage points. And also compared to this intermediate state of the art by Schmitt and colleagues who trained the CNN using fast text embeddings in 2018, who were some percentage points better than the kind of baseline from back then, but yeah, BERT was obviously superior to these models. And for the last subtask, the Subtask D, for this I have to mention that we trained each model basically twice, once with a CRF layer on top and once without. And the models with CRF layer consistently outperformed their counterparts without the CRF layer, which is why I'm going to show you just the results using the CRF layer on top. And in this case, we were even also able to outperform the results from back then, which were achieved by a simple CRF by Robert and colleagues by a large margin. Also, they had these two distinctions here. One, the one subtask of Subtask D, namely D1, was just measuring the exact match, whereas here the tolerance was ±1 token, which explains why the scores here are consistently higher than over here. So what are the main takeaways? What can we learn from this? We basically saw that the uncased models, in this case, had a tendency of outperforming the cased counterparts. For the monolingual models, for the multilingual models, this is not that obvious, and we cannot that clearly confirm this. But we also saw that the monolingual models outperform their multilingual counterparts. What we also observed is that there were no large performance differences between the two cased BERT models. And I'm talking about these two ones up here, the one by deepset.ai and the one by dbmbz, which potentially suggests that the different pre-training corpora they used only have a minor influence on the final performance. What also caught our eye is that the monolingual BERT model is pretty competitive. It, for example, outperforms its multilingual counterpart, which we also already observed up here. But also the larger BERT models on the subtasks A to C, and is also sometimes pretty competitive to the monolingual BERT models. So last but not least, let's get to the GermEval 2014 shared task, which was introduced by Pontiki and colleagues in 2014. It is an English data set which contains review data on restaurant and laptops. And also they formulated different aspect-based sentiment analysis related subtasks, namely SB2 until SB4. SB2 is also kind of, we have an overview of this in the paper, but it's only related to the tasks we have here, which is why I will skip this on the slides today. Since it is about aspect term polarity. And the difference here is that aspect term is basically a word which is always has to be present in the review, which makes it kind of different from what we're doing here. Kind of similar to our subtasks C1 and C2 are SB3 and SB4. The former is aspect category extraction, which is exactly what we do in C1, while the second one is aspect category polarity, which is exactly what is done in C2. One difference is that this task seems to be somewhat more easy, because here it is always only a 5-way classification. And again, down here, plus 3 sentiments, so only 15 classes, remember, compared to the 60 we had in C2. And this maybe also partly explains why the pre-BERT scores for the GermEval data were already much higher than they were for the C2. You can quickly go back and see for C2, the pre-BERT scores basically were around 46%, 47%, and here they were already at kind of 84%. Yeah, maybe a somewhat easier classification task. And here we can also observe some kind of a jump by 6 percentage points, which might not seem that much compared to what we observed here, by over 20 percentage points. But yeah, my feeling is basically if we compare this to the potential room for improvement, which is only 16% here until we reach 100%, which was much larger for our case for C2. Maybe if we set this into relation, then it's kind of comparable. The performance jump, which happened through the introduction of BERT. But it's only some gut feeling that it might be suitable to set this into relation. And one last word from my side, then I'm done. The suspicion we had why the uncased model performed best is, we have data from social media here. So this might be pretty noisy, and many of the participants from 2017 also did a lot of pre-processing to clean the data accordingly. And maybe using the cased versions still keeps the noise inside the data, while the uncasing the text maybe filters this out to some extent. But that's just a suspicion, because why the uncased model might perform superior here. Yes, and that's what we did on re-evaluating this GermEval 2017 task. Thanks a lot for listening, and I'm happy to discuss this further and to answer your questions.
Okay, thank you very much. It was very interesting. So again, I invite all participants to ask their questions. Maybe I'll start with one. So, I mean, I'll pretty much join with what you just said. So I imagine that since it's social media, that probably people were not very consistent in their own capitalization. So that's maybe one influence why the uncased model worked so much better. So I think it's a very intuitive explanation you gave. And
yeah, it might work as some kind of filter, like filtering out this additional noise introduced by the source of social media.
Yeah. So I mean, I find it very, very cool to have like this very thorough comparison from like this pre-BERT to post-BERT, which in itself is like a cool concept. Like we've come so far in a few years. I mean, are you gonna do like similar studies in the future, like with different data sets? Do you have anything planned?
Yeah, it was something we came up basically on the fly. I mean, the whole master thesis project of Alessandra started out with the idea of, hey, it might be cool to have a look at this old data set and look how BERT can improve this. And then we wanted to do kind of something more for discussion part of the paper. And then we came up with this, we stumbled across the GermEval data set, which is pretty popular. And then we kind of digged into the literature and had a look at also this papers with code homepage, which was pretty helpful because there's a pretty thorough overview on many such benchmark data sets. But yeah, I think it's important to have a look at the influence of these pre-trained language models to different kinds of tasks, domains, and data sets. One more thing is that unfortunately, this SB3 and SB4 tasks were not that popular compared to SB2, which was just this aspect term polarity. And for this SB2 data set, we weren't able to detect such a jump introduced by the introduction of BERT. But we couldn't really figure out why this was the case, just an observation that this wasn't quite the case.
Yeah, very, very interesting. So